Bismillahirrahmanirrahim. Assalamu alaikum. In today's video, we will learn how to make a 4-bit arithmetic logic unit by using Keypad on Proteus and how to simulate it. So here you see, this is the problem statement in which we have these conditions. We have to make the block diagram. System should take input from Keypad and our system should perform desired operation. And we have to show the output of our system on 7 segment display. So first of all, we have to make a truth table, and by using the truth table we have to make the expressions of our output. So let's make the truth table. You see on the screen I have made the truth table of our input and output. Actually these are not our final outputs. These are the input and outputs of the 4 8 cross 1 muxes that I have used. A, B, C and D are the inputs, 4-bit inputs of our muxes, and Y0 is the output of mux 1 and Y1 is the output of mux 2, Y2 is the output of mux 3 and Y3 is the output of mux 4. So from these 4 muxes, then these 4 outputs go to the D-latches, and then after D-latches the inputs sent to our multiplier and adder circuits. So by using these combinations I have made the expression for our muxes. Now I show you the equations that I have made from this truth table. Now you can see the equations for Y0, Y1, Y2 and Y3 for mux 1, 2, 3 and 4. I have made these equations by comparing the output Y0, Y1, Y2 and Y3 with the input A, and after creating the combinations of 2 inputs and 2 outputs I have made this relation with the output and inputs, where you can see the Y0 relation is A bar, A bar, A bar, A bar, A bar and A bar. Here you see on Y1 A bar and A and 0 represents the permanent low output, and similarly in Y2 1 appears which represents the permanent high output. Means that whatever our input is, the Y output at that input remains always high, and similarly at 0 the output remains always low. Now by using these expressions I will make the connections of terminals of 8 cross 1 muxes. Now I will show you the block diagram of our circuit. Here you see the block diagram where the inputs coming from Keypad, then 8 cross 1 4 muxes I use to convert these input from the Keypad into binary number, and then 2 D-latches are used. Actually here I am using the D-latch to save the input numbers. When I will enter the one number from Keypad, then I will on the D-latch 1 and save this value on D-latch 1. Then by giving the 00 on clock and clarity of D-latch, I will hold that input on D-latch 1. Now I will give the second input from the Keypad, and then by open the D-latch 2 I will pass that input from the D-latch 2, and then after that I will give the 00 polarity on clock and polarity terminal of D-latch 2, and then save that input on D-latch 2. Then after these input 1 and input 2 from D-latch 1 and D-latch 2, I have made the circuit for adder and subtractor and multiplier. For adder and subtractor I have used the IC 74LS283, and for multiplier I have used the IC number 74285. In adder and subtractor circuit, in the IC 74LS283, here is the enable terminal. When the enable terminal is 0, then this IC will perform the adder operation, and then when that enable is 1, this IC will perform the subtraction operation. Now we will see how we can perform this circuit on Proteus. On this screen you see that by using that block diagram I have made this circuit on Proteus, where I am using this keypad and this ID is used to convert the decimal input from the keypad into a binary number. And then these 4 8x1 muxes which I have made by using the expression that I show you earlier for y0, y1, y2 and y3. Here I have made the input connections of for muxes and the single output from muxes. Then these outputs go to the D-latch. D-latch one output is from y0, from y2, from y3 and so on. Then these D-latches are used to save the input. When I am giving the first input, I will store that input on D-latch 1, and when I am giving the second input, I will store that input in D-latch 2. Here you see these two logic toggles. When these are 0 0, D-latch will hold the input that is saved in it. And here you see the logic probes. When these are 1 1, then D-latch will save another input, and when I am changing these probes into 0 0, then that D-latch will hold the input that is saved in it. Then after these D-latches, the inputs go into the adder circuit, and similarly the input go into the multiplier circuit. Here you see this is the IC that I have used for multiplier, and this is the IC that I have used for adder and subtraction. In adder and subtractor IC, here you see the C0 terminal. When this is 0, this IC will perform the addition operation, and when this will be 1, this IC will perform the subtraction operation. This is the 7-segment display that will show us the first input number, and this is the 7-segment display that will show us the second input number. And similarly, these 7-segment displays will tell us our outputs. Now when we run the circuit, first of all I am giving the first input number, suppose that is 3. Now I have given the 3 input from the keypad. Now I have to save that input in D-latch 1. So I will hide the clock and polarity of D-latch 1. Here you see the first input number is 3 and that is present in D-latch 1. Now I have to save, means I have to hold that input in D-latch 1. So I have to give 0 on clock and polarity of D-latch 1. Now you can see our first input is 3, that is hold in the D-latch 1. Now I am giving the second input, suppose our second input is 2. Then after the keypad, now I have to show that input in D-latch 1. So I have to give high on the clock and polarity of D-latch 2. So D-latch will pass that input, and here you see on the second number our input will become 2. Now I have to hold that input in D-latch 2. So again I have to give 0 on clock and polarity of D-latch 2. Now our both inputs are holded in D-latch 2 and similarly in D-latch 1. So our first input number is 3 and second input number is 2. Then here you see the C0 of IC is 0, so this IC will perform the addition operation, and 2 plus 3 is equals to 5. And similarly this is our multiplication IC, so 2 cross 3 is 6. Now when I have to change the input at any of the D-latches. Now suppose I am giving the 3 input. Now I have to choose on what D-latch I have to store that input. Suppose I am storing that input on D-latch 2, so again I have to give 1 1 on the clock and polarity of D-latch 2. Now you see here on the screen our second input number becomes 3 because I have changed the input on D-latch 2. Now again I have to hold that input on D-latch 2, so again I am giving the 0 0 on the clock and polarity of D-latch 2. So our first number now is 3 and second number our is also 3. So multiplication is 3 cross 3 is 9 and addition of 3 cross 3 is 6. Now if I perform the subtraction operation here in this IC, then I have to give the 1 on the C output, and now you see this IC will perform the subtraction operation and 3 minus 3 is 0. So by using these ICs and multiplexer and D-latches, you can easily create a 4-bit arithmetic logic unit on Proteus. And I have shown you the truth table for the multiplexers because this is our main task when we have to use the keypad in our circuit. So we have to use these muxes and D-latches to store our inputs. So this is our main task, to store that inputs, and then after that here it is the simple addition and subtraction circuit, and it is the simple multiplication circuit. So that's enough for today. Thank you.